Everybody, welcome back to Beyond Basics with Madiha. In today's video, we're going to take another interesting problem from arrays. How to find the second largest element in an array. If you're new here, make sure to like, share and subscribe to my channel for more such helpful DSA content. Also, if you've missed the previous video of mine in which we've discussed how to find the smallest and largest element in an array, I highly recommend you to watch that first because this video is directly connected to that one. Watching that first will give you more clarity and continuity to this problem. So link is in the description. Make sure to watch that first and come back here later. Alright, without any further ado, let's get started. So the problem statement that we have here is find the second largest element in an array. As we discussed in the previous video, step 1 to approach any problem or to solve a problem is going to be to understand the problem with more clarity. And here it is. The problem statement here is to find the second largest element in an array. Let us understand this better in deeper dimensions by making use of an example. So if you see here, we have an array of integers 12, 35, 1, 10, 34 and 1. And the answer, the second largest element among this array is going to be 34. Why so? Because 35 stands to be the largest element in an array and 34 is the second largest element in an array. You don't see any number that is less than 35 or greater than 34. So obviously 34 is only going to be the second largest element. So we are clear with the problem statement. We've understood this better with an example. Now let us look into how to solve this problem further. Now in the previous video, we solved a similar problem wherein we found the largest element from an array plus the smallest element from an array. So this is similar to that problem. There we found the largest element. Here the only twist is we are finding the second largest element instead of the largest element. So if you start comparing the problems here, how the solution remains probably the same because we already have the understanding of how to find the largest element. That is, we keep a variable called maximum and we start comparing every integer and we find any integer that is greater than the current maximum value, we update the maximum value accordingly. But here we do not just want the largest element. Instead, we want the second largest element. So the technique here is going to be the same. Wherein there we had largest and smallest, here we will have largest and second largest. And we will start with the same approach here. So initially the largest value is going to be the minimum value, second largest value will also be the same. And one by one we will iterate the elements from this array. So initially it is going to be 12. Now we will see if this 12 is greater than the largest element that we have. Obviously it is greater. So this will become the second largest element is going to be the largest element. And the largest element will become the num. So what are we trying to do here is whenever we find an element that is greater than the largest element, obviously that is going to be the largest element from the array. And the second largest element has to be smaller than the largest element. That is why we delegate the largest element to second largest element and the largest element will become the new element that you put in. Alright, so again it's the same process. The only thing is we are delegating here. There we only took largest element and smallest element and we kept comparing. But here the understanding is if you have the largest element, then the pre-existing largest element is no longer largest element. Then obviously it has to be the second largest element. That is how we make the transition here. So 12 is greater than the largest element. So largest element will become 12 and whatever value you have in the largest element will become the second largest element now. And we move on. Now again we see 35. So 35 again is greater than the largest element 12. Yes, 35 is greater than 12 because now the largest element that you have is 12. Right? And 35 is greater than 12. So now what will be the largest element? Largest element is going to be 35. And what do? We have got the largest element. Now the second largest element has to be 12 obviously. So what do? We make a shift. Now the second largest element becomes 12. And we move on. Now again we see 1. So 1 is greater than 35? No, it is not. So we move on again. So 10. 10 is greater than 35? No, it is not. 34 is greater than 35? No, it is not. 1 greater than 35? No, it is not. But if we follow this approach only, there's one thing that we've missed. We come up, we deduce 35 being the largest, which is correct, but 12 becomes the second largest, which is not correct. It's incorrect, right? Because 34 is the largest. So if we stick or cling to this approach, then we may not deduce the right second largest element. That is why we introduce an additional condition. That is because, in case if you come across an element which may not necessarily be greater than the largest element, but it can be greater than the second largest element. 34 is not greater than 35, but it is greater than 12. That is why we introduce this additional logic. If you come across an element which is not greater than the current largest element, also cross check with the second largest element as well. Why? Because if you have 34 not greater than 35, then it comes to this else condition and it will check. 34 greater than second largest? Yes, it is. 34 is greater than 12. And we have another condition that we've sticked to. What is that? And that element should not be the largest element. Assume that this is 35 again instead of 34. If you have 35 not greater than 35, yes, it is true. So again, 35 we are comparing with 12. 35 greater than 12, yes, it is. So if you don't have this logic, then what happens? Your second largest element will become 35, which is not true because it has to be 34. If 35 is here, then obviously it has to be 12, right? So we again are not getting the right second largest element. That is why we again have this condition also. That is, we compare, once we come across an element which is not greater than the largest element, then we go and compare it with the second largest element, because there may be a condition where we have a number which is not greater than the largest, but it can be greater than the second largest. But when we compare it with the second largest element, we also ensure that we are not comparing it with the same number as larger. Okay, this is not a duplicate number of larger. That is why we introduce this logic. Now let us dry run this example again with the entire code snippet. Okay, so we initially start with 12. So initially we have the minimum value as largest. So 12 is greater than that minimum value. Yes, so this becomes the largest element. Since this if condition is satisfied, it does not move or delegate or make a transition to else if. Alright, so we move on 35. 35 is greater than 12? Yes, it is. So now 35 becomes the largest and 12 becomes the second largest. Okay. Now we move on to 1. So 1 is greater than 35? No, it is not. So we again come across and see with this else if condition. 1 is greater than 12? No, it is not. So we move on. 10. 10 greater than 35? No, it is not. 10 greater than 12? No, it is not. 34. 34 is greater than 35? No, it is not. 34 greater than 12? Yes, it is. And 34 is not equal to 35? No, it is not equal. So what will be the second largest element? Now the second largest element will be 34. We move on. 1. 1 is greater than 35? No, it is not. So we again compare 1 greater than 34? No, it is not. So finally, we've come to the correct deductions now. That is, 35 is our largest element and 34 is the second largest element. I think we've got more clarity on how to express how this code snippet is deduced and why do we introduce this else if condition. Okay, and then we print the second largest element. Now, as discussed previously, what will be step 3 or step 4? Edge cases. We always have to worry about the edge cases because, like discussed earlier, some test cases you might clear up with the direct approach that you begin with, but there can be some hidden test cases where you cannot, because that's based on the edge cases. Now, if the array contains all elements equal, for example, 5, 5, 5, then there is no second largest element, obviously. So in such cases, you'll have to figure out what should be the value that you return. What should be the second largest element. So always pay attention to the edge cases, negative scenarios also. This is one of the edge case. There can be other edge cases also, right? There can be where you have all the elements equal. There can be non-negative numbers as well. So in such cases, how do you go about? You'll have to think. So once you deduce an approach, an algorithm that you stick to, you should ensure that this algorithm is robust and it stands tall for all the test scenarios, that is negative numbers, positive numbers, what if everything is equal and all of that. So simple as that. So once you understand the problem, you understand this better with an example, then you start coding the problem, then you worry upon the edge cases. Now the final step is we reduce the time complexity. Now since we have only one loop and we traverse the array only once, so therefore the time complexity is big of n, which is minimal. Already we have the optimized solution. And the space complexity is big of 1 because only we've created two variables. So nothing else we've done apart that occupies more space. So this makes our approach very efficient. So we have the optimal approach and we have it with less time complexity. This brings us to the end of the video. If you found something knowledgeable, then do like, share, and subscribe to stay tuned. And we shall see you on the next video of DSA.